So today we'll be talking about the topic consume existing Ceph storage with Kubernetes with Rook. So let's start. Myself, I am Parth Arora. I work for IBM Storage as a senior software engineer. And I will do a fun activity here, like raise your hands if you know about certain things. So how many here are familiar with containers? Okay, I see a couple of hands. How many do know about Kubernetes? Okay, I guess less hands. So anyone used Rook in production or familiar with Rook? Okay. So that's fine. Like then I can start with like a basic and then we can go ahead. I guess that would be a good new learning and a new topic for you guys. So let me then start with containers. What is a container and why it's used in the industry. So you guys might be developing some code right here and there, and you might be sharing with different friends. But the problem is you will share the code, but you don't share the dependencies of it. By dependency, I mean if you are writing a Python program, you share the Python program to your colleague, but it might not work into their machine. Why so? Because they might not have that Python dependency in their program. So what industry use right now is they create a container out of it. What it does is like it package the code and the dependencies and the specific versions of those dependencies. So once you create that container image, if you give it to your friend, it will eventually work into their system depending on which distribution they are using. If they are using Linux, you will give a Linux image out of that. And if they install that image or use that image in their system, it should work fine. So that's why it's a container that we have, like it wraps the code and the packages that are used for that particular program to run. Because in bigger programs, there are a lot of dependencies. And even dependencies have different versions. So to maintain that, we create those containers and images. So I guess containers, you guys might be fine with that. So these days, like companies would be creating so many containers out of that. Like each service, we talk about microservice. So UI would have their own container. Backend, they have their own container. Networking have their own container. So we have a lots of container. So how you will manage it? You can't manage a single container by yourself. So that's why we introduced this Kubernetes. It's an orchestrator. So I guess you guys might be there interested in that tabla fun activity, right? So there was an orchestrator that was orchestrating us. Like they were they were increasing the tune voice, then we were also increasing the tune voice, and they were decreasing. And they were calling specific people to play tabla and specific one to stop. So it's the same what Kubernetes does. It's an orchestrator for containers. It tells when to scale down, how to manage, how to auto heal, like when you have to clap or play that tabla very loud, and when you have to play that tabla slowly. So it's the Kubernetes working, the main orchestra that has. So that's why we want Kubernetes, and it's an open source project developed by Google, Microsoft, and other companies. And that's why Kubernetes is being used nowadays if you are having multiple containers and you want to use microservices. So here's the architecture of Kubernetes. If you see, like here's the orchestrator that the person was there. And we are like different rows. Like there were a couple of rows, right? We were 3 rows there after the orchestrator. So these are different nodes where the orchestrator will say like how to process those nodes. So this, don't go deep if you don't know much, but here's the controller that tells like how to work. And there is a scheduler that will say like which one to play the tabla. And similarly, we have a API server, like that's the server side and that's the client side. And etcd, that's a key map value store. So just a basic high level overview if you want to take, but just think on a way that we were playing tabla yesterday and you can understand the other logic. Then we come to like this Kubernetes was developed and it doesn't kept the storage side of applications when they were developing Kubernetes. So mostly you see nowadays like the applications is stateful. By stateful, I mean every application has storage. If you even create like a login page, you will have storage with you, right? So Kubernetes was a good platform for us that has developed, but it doesn't care much about storage or doesn't has a good solution for that. That's why we look for like how we can bring our own storage to Kubernetes. The first thing everyone would be having in mind is like, I have AWS S3, I can just connect, plug and play. That's the easiest solution. But what enterprises face issue is like, if you go on scale, then there are problems with these cloud providers. If you are talking on scale. So why not to bring that storage to your own data center and manage that storage how you are managing other Kubernetes applications. So we are managing storage with these Kubernetes. And you will also see like, if you go on scale, even these cloud providers has some certain limitations with it. Like the number of PVs it has, like how many storage or how many, I would say if you are playing a tabla, like how many people can be in a row. There are some limitations to these cloud providers. But if you are in an enterprise, then your business grows, then you need more storage. And you need to scale your storage with Kubernetes. So to overcome those solutions, we are thinking of a solution to develop. And we didn't want to develop the actual storage solution. So we want to see like what we can pick from the industry. So Ceph was already used by enterprises, and it's like a scalable platform, and it's trusted by enterprises. So we bet on Ceph to use that as a storage solution. But Ceph was built like a far away when the Kubernetes concept was not it been introduced. Kubernetes concept is like a decade ago, but Ceph is a very old. And I will tell like what benefits, what we can get from Ceph is like Ceph provides block file and object storage at the same time. If you are not knowing about what's block file and object is like, block is like if you are running a MySQL server, the storage that is coming from MySQL is the block type. And file is like if you are having a Windows PC, the storage that you have is the file storage there. And object is like S3 buckets. You heard about like AWS S3, like if you want to store videos and a lot of data that has like in a less efficient cost, so then you can use S3 for that. So it's very cheap, and if you want to store all the video and other things, objects, then you can use the object storage. So Ceph provides all these three objects at the same time, the storage. And what all it has is like, it is designed to be consistent, and it's resilient. By that I mean like, if you are storing a particular piece of data into Ceph, what it will do is, it will have different zones. Let's say first zone is in US, second is in Europe, and the third is in India. So what it will do, if we are storing the data through Ceph, it will replicate that data to different available zones. So let's say the replication is 3, then I will have 3 copies of that data into different centers or areas. So that's why if you are having some disasters like at US and Europe, you can still access the data from India. So that's the main factor that we get from Ceph. So these are some good points that why we bet on Ceph. Now comes the Rook. So as I mentioned, Ceph was already developed from a far back. So we created an operator, Rook operator, which actually brings Ceph to the Kubernetes world. So bringing back to the same example where we were playing tabla, so that orchestrator knows some tunes. They were telling like, play these beats. But in real world, in business use cases, we have their own needs. We want like our own logic as per our business. So I need to instruct that tabla, the orchestrator, to like play certain beats. So I have to explain that. So that's why Kubernetes provides us an operator form where we can tell our own logic to Kubernetes that work like that or play this tune when as per my business use case. So that's a Kubernetes operator, and that's the Rook in actual. And it has like, if you're familiar with Kubernetes, it provides a simple CRDs, that's a custom resource definition. It's just a YAML file where you can use for configuring like how you want your storage to be look like. And in that fashion, like it actually brings the Ceph to the Kubernetes world. So if you talk about like how the architecture looks like, it has like Rook at the top, that's the operator. Then we have Ceph CSI that actually provision the volumes. By volumes, I mean you have a storage, you have a bare metal with you. You have like a box of storage. Now you have to provision that to your Kubernetes volume. That's the part of CSI. And we have the Ceph as our data layer. So this is the main architecture that we had. And Rook operates on 2 modes. Like if you want Ceph to be natively installed with Rook, That's the first way. And the second way is the external mode, where you already have a Ceph cluster. As I told, like it's an enterprise thing, and many companies already run Ceph cluster as their storage solution. So if they want to bring that to the Kubernetes world, we can use that external way connection to bring that Ceph cluster to the Kubernetes. So that's the Rook Ceph external. You can see like external Ceph cluster is running, and then a Rook operator will work in external mode, and it would be bringing that external Ceph cluster to the Kubernetes cluster. And why it's needed, like it has some privileges, like you can connect different tenants of the cluster at the same time. Let's say you have a finance department, you have a IT department, everyone needs storage. So if you want to connect, if you want to connect like all of these in the same cluster, that's a privilege we get in external mode. And if you want to totally isolate your storage with your application. So there are cases like where you don't want to keep the Kubernetes in the same where your Ceph cluster is running, because there might be cases where we are using or utilizing the resources that we have given for Kubernetes cluster. So that's why if you want to keep separate, we can use the external mode. Here's the diagram. I can give a site if you want to click a picture. So there is the cluster admin. What it will do, it will scrape the data from the provider cluster, that's the external standalone Ceph cluster. And in the consumer cluster, it will go and import the dependencies and do whatever operator should do for creating the storage. And the end, what we need is a storage class. A storage class is something, if you have a storage class, we can give it to the application. If you are using AWS, they would give a GP2 storage class and you can directly connect. So at the end, you will give a storage class. You can create a PVC out of that. That's a persistent volume. Like if you have a persistent volume, if you store something in that, it would be persisted. And you can use that persistent volumes with your pods. Here's some simple logic like how you have to install it and all. You have a Python script to scrape that data that I told. Like they have to scrape that data, so you run a Python script, you scrape it, you run some files, you create some CRDs, and your cluster will be connected and you can use Rook Ceph in the external mode. Here's the demo. I've recorded it because I see like most of the live demos break, so I've already recorded it. Let me go and play that. So moving on to that demo, I see like most of are not familiar with how Kubernetes is there, so I will make it very quick. So here's the external Ceph cluster. What I'm doing is I'm extracting the details from that. So as I mentioned, like I would be running a Python script here with certain parameters like what config I want. And once those Python scripts are run, it will give a output to me, the export output. And let's say like how you use user credentials. These are the user credentials for that Ceph cluster. And I will give that user credential to the Kubernetes cluster. And that Kubernetes cluster will go and create certain YAML files. So those YAMLs are created. And so I will show once like it takes time to reconcile and all, so I will move forward. So this is how like different pods are looking like. So these are our, let's say these are the pods. We were playing tabla, so we are the pods here. And once it's created, I will show the main, like the hot topic, what I want to show here. So once a PVC and that is created. So what I'm doing, I'm creating a WordPress MySQL server. So I will wait once it's started. And what I will do with this MySQL WordPress server is I will store some data to this MySQL WordPress server. And at the backend, what it is using, it's the Ceph cluster. And you remember like Ceph is very much replicated. It will, even if there is a disaster at certain nodes, it will still persist to your data. So I will go to this server, go inside this server. Yeah, I have escaped to this server. I will create a file, a demo file, I guess. So there is a persistent storage. I will create a demo file. I will write, I will be persisted even if it's a disaster. And you will see like, even if I go and delete this pod, so after that I will go out of this pod and let's say my pod got deleted. There is a node failure and my pod got deleted because my US server went down. So at US, let's say this pod gets deleted. So what Kubernetes will do, it will create another replica of that pod. And if I go to the, let you see, like it's 9 seconds ago that another pod has been created. And you see if I will escape into that pod again, and if I go to the certain path that I was going back there, that is the persistent path. And if I see that my file, you can still see that my file is still present there because that's persisted at the Ceph layer. So that's more about the demo, I would say. And coming back to the slide, so we have certain features there if you are specifically interested in Ceph. So we have a couple of new features, I guess not relevant for now, but these are some new add-ons that we have done. And these are like the reference. It's an open source project, and these are some reference guides you can take a look. It's open for contribution for other guys. You can contribute, and we love to have new good first issues and good contribution there. And we are looking for that because it's always a work, and you see like it's an enterprise product, and every time it's a lot of work. So good if you can start with it and then end up having a full time there. And the Q&A, and there is a barcode that would takes to my LinkedIn profile if you want to connect. And any questions from the start of the topic related to Kubernetes or anything? Okay, I guess. Okay, sure.
So my question is mainly about the managing the Rook cluster in a multi-cluster environment. So let's say I have a fleet of bare metal servers, and on the top of it, I have a multiple cluster running, right? So you can, let's say, like 10 total bare metal server, and then 3 to 4 Kubernetes cluster I'm running, right? So what is your suggestion, and what the customers are using? What is the industry trend towards using this storage cluster? Are they, inclined with that more, having a different Rook server? I mean that the Rook has been installed in all the Kubernetes cluster, or it is externalized. So what's the people are opting for, and what is the pros and cons of using one on another approach? So that's mainly my question.
Okay, that's a very good question, I would say. So if you see, like here is the Ceph cluster, and we are connecting to different external cluster. So mostly customers having the Ceph cluster installed by default, like the Ceph was being introduced far back. So the customers who already have the Ceph cluster as a data layer, they prefer to go with the external mode. And uh, and the benefit here is like if you're connected to different Kubernetes cluster here, uh, you will like give a specific kind of resource. Like if you're sharing the common Ceph cluster resource to different clusters, so we'll make sure like we'll give minimum privileges to each cluster, whatever they are required. So our data is being isolated between different clusters that are being running. Will give a specific privilege or a scope to each cluster in this case. And there is another use case that we have added is like if you are not in external mode, you are in internal mode where Rook is installing the Ceph itself. There also you can install multiple Ceph clusters, and there is a good thing that we have introduced is the device class. So device class is something that segregates your devices between different labels. So if you guys understand, there are OSDs that's has been called as a device. By device, I mean the actual box of storage. So we can label those devices between different labels. That is called device class label. So you can label that with different device class and consume with different applications. If you don't want different Kubernetes cluster, you can use that way to consume the application using labeling the actual devices and creating a separate pool and the whole hierarchy that I mentioned.
So this device class help us to provide the isolation assurity to my individual tenant, right? Because this whole cluster ABC is occupied by different teams, and there are different CTOs who are owner for these clusters. So they would need, the words of isolation. For example, here also the pool A, B, C, it may be in different nodes on my storage
Yes,
server, right?
correct.
So we wanted to make sure that there is enough OSD available for the cross replication perspective, as well as we want to also make sure that there is a strict isolation from compliance and the scrutiny and data auditing perspective.
That's correct. Like even I would say you can still use the device class here, even if your Ceph cluster is standalone. You can like currently what we'll do is data coming from different clusters would store to same devices. But let's say now you want like specific, like there are SSDs and SDDs in the market. You want your some applications that really want performance, you will choose SSDs over SDDs. So you can label those applications here also using the device class to store the data onto that specific OSDs only, and you will create a pool out of it. And you can similarly create a pool with SDD with that and extract and give to the different Kubernetes cluster. So both the ways, as per your business logic, you can think on what you want to go. Okay, thank you. Any other question? Okay then, thank you. See you guys.